Okay, so I hope I'm audible to everyone, and today we will solve another problem, which is segregate even and odd nodes of given linked list. Okay, so first of all, we just understood the problem, and after the understanding the problem, then we jump to the approach and implementation part. So in this given question we have given a input in the form of linked list like 17, 15, 8, 8, 12, 10, 5 and 4. So in this problem what can we do? We can segregate the all even element like 8, 12 and 10 and 4 in one part, like, and other part we segregate the odd element. Okay, like 17, 15 and 5. And ordering is matter, like here ordering is first all even node and then all odd node. All right, and another important things in this important nodes in this question, order should be maintained. All right, what do you mean order here? So order is like if 8 is coming before 12, so in the final result 8 is must be coming before 12. All right, I hope you understood what is the ordering here. Okay, so uh, in this uh, output, like output of this given input is 8, 12, 10, 4. We segregate the all even element and all odd element. All right, and then just combine it, and ordering is not changed, like 17 then 15 and then 5. So ordering is must be preserved like this way. And for the even element, ordering is like 8, 12, 8, 12, 10 and 4. So in the output, ordering is also must preserve like 8, 12, 10 and 4. Okay, so let's take another example for better understanding. So in this given input, all element are even. So in if given linked list has all element is even, so in this case there is no odd element, so our output will not change, so we will return same linked list in the output like 8, 10, 12. And similarly, if we get a input where in the linked list has all element is odd. Okay, so there is a no even element even node in linked list, so in this case we have to just return the original linked list like 5, 7, 9. All right, I hope you understood the problem. Let's jump to the approach. All right, so the first approach in comes in my mind is like we delete the node from the beginning. All right, so in this first approach, we delete the node from the beginning and insert into the last. What do you mean? Let's take example. So let's our example is 7, 7, 12 and 7, 12 and 4. This is an example. So we start like in the first step. Uh, we have to add the last index like at the here. Let's take let's take an example. And 4 is we take a pointer index which is pointing to 4. Okay, so uh, it is a last element of linked list, and again we traverse the again linked list. So 7 is an odd element, so we have to just delete the 7 and insert into the last. So after the inserting the 4, the 4 next is 7. So there is no other odd element, so our output should be 12, 4 and 7. And then we will return this is a head node, so we will return head. So In this case, output should be this. But the problem in this approach is we traverse two times linked list. First for the at the last index, and second for the deleting the node, odd node, and insert into the last. So this is a if you talk about the time complexity, so it takes big O of n and big O of 1. It's space complexity, but take two traversal. Okay, let's move to the another approach, which is better than this approach. So in this approach, what can we do? In this approach, we have to just reversing the linked list, reverse the linked list and connect all event node into one linked list. Okay? And similar for the odd, like if we have linked list which are odd and also even, so we will segregate during the traversing the linked list. Okay, so this way. And after the all step, like after the traversing the linked list, we just connect to linked list, both linked list. Okay? and and then we will return this this head part. If we return yes, so we get a required result. So let's move to the uh, taking an example, and also with the help of code we will understand this problem. So, this is a code for this problem. Let's take our example. Take 17, 15, 12, 12, 5, 6, and 4. Okay, this is example, and initially we have 4 pointer, and all pointer we assign null into, like ES is also null, and double E is also null, and ES means even a start, double E means even end, and OS means odd start, and OE means odd end. All right, and initially we will put null into that. Let's reverse the whole all linked list with the help of for loop. So initially the current has next head. So initially head is pointing to 17, and this is, and after the first step current is also pointing to 17. All right, and after the second step, what can I do? We take a x variable. Okay, and in the x variable, it's a temporary variable, and we store the value of current data. So current data is 17. All right, and in the second step, what can we do? We can check whether the 17 is even or odd. So if you observe easily manner, so it is observed that 17 is a odd number. All right, so 17 is odd number, so we will uh, jump to the this part. All right, so 70 is odd part. Okay, so we will jump into else part. So in this else part we can check whether the OS is null or not, null or not. So initially OS is null. All right, so in the OS both are null, so we can in the insert current into the OS. So then initially first step OS is pointing to this one, and also in the second step OE is equal to OS, so OE is also pointing to 17. Okay, so let's move to the next current next. So current next is 15, and it is also odd, but in this case OS is not null because OS is now pointing to 17. So in this case we jump to the else part, and in the else part we will make operation OE next is equal to current. So OE next is equal to current, so we make a 15 here, and OE is point OE next is 15, and in the second step OE is equal to OE next, so we will move OE from here to here. So now OE is pointing to 15. All right. Okay, so and then again we move to current into the 12. So x is 12, and we know that 12 is even number, so we will check this else if condition. So in this if condition we will check es is null or not. So here even a start is null, okay, because initially all even a start and even end is null, so we will assign current into the even a start. Okay. So 12 is assigned even a start, and also in the even end we will assign even start. So even end is also pointing to 12. So let's move to the next node 5. So here is a 5, and 5 is odd element, so we are jump to the else part. All right, so in the else part we check odd start is null or not, but here odd start is not null because odd start is pointing to 17. So we jump to the else part, and in the else part the first operation is OE odd end next is equal to current. So odd next, okay, let me know, and it is from the here, and 12 is pointing to even s and even end. And then the first step OE next is equal to current. So OE next is equal to current, so we write down this way, and in the next step we update the odd end. Let's move to the another node. So current node is 6, and 6 is known as like 6 is even node. So we will jump to the if condition, and we check whether even a start is null or not, but here even a start is not null because even a start is pointing to 12. Okay, so let's move to the else part. So in the else part what can I do? The first step is e next is equal to current. So e next is current, so we update this value e next is equal to 6, and after this and first step, the second step is update the even end. So we update the even end from here to here. So now even end is pointing to 6. Okay, let's jump to the next node. Okay, so next node is 4. So now the current node is x, and it is a it is a event. So we jump to the else part and if part. So we check whether in the start is null or not. So here in the start is not null because in the start even a start is pointing to 12. So we jump to the else part, and in the else part what can I do? There are two steps. In the first step, in the next even end next is equal to current. So even end next is equal to like 4, and we update the even end. Okay, so now even end is pointing to 4. Okay, let me these which are not important for here. So after the iterating all the whole linked list, okay, because after the iterating we are jump into the like current will be equal to null pointing to here, current is equal to null, so we are out of the loop. Okay, when we are out of the loop, so there are certain condition. Okay, let me erase this. So we are at the last step. So in the last step, what we can do, we first of all we check this condition. Okay, if anyone like order start and even a start is null, so it means this is jump into the a particular case like 12, 14, 14, 16. In this case, odd order start is null. Why order start is null? Because of there is no odd linked list. That's mean there is a order start is null, and in this case we will return head node. Head node because head is pointing to 12, and if we return head node, so it's return original linked list. Okay. So in this case, this is not our case because no one in either order start and even a start, no one can be null, pointing to null. So we will jump to the else part. So in the else part, we connect the node because we have odd and even node, but we have to just connect the node to one, and after that, so in, in this case, e next to like even end next to order start. So we will connect this to this one, and in the next step, odd end next is equal to null. So odd end is here. So odd end next is equal to. So after the performing the all step, our link list will be look like this. Right? And when we return even a start, so because all node is connected, let me write down in the better ways like 12, 12, 6, 4, 17, and 15, and 5, and null. So even even a start is here, and even a start is here, and even end is here, and odd start is here, and odd end is here. So if we return even a start, so we get a required linked list. Okay, so in the final step we will return even a step. Okay, let's talk about the time complexity. So time complexity is below of hand because we just here simply traverse the whole linked list. And if you talk about the space complexity, so here we don't use any extra space, so space is of 1. This is time complexity and space complexity. I hope you understood this solution. This is also not much, I think easy problem with GFG. Okay, you can also solve by yourself. And thanks.